Hello students, today we will discuss H parameter representation of transistor. In the previous video, we discussed the basics and need of H parameters for representation of transistor. That is also called as modeling. H parameter modeling of transistor. That's what you should remember, that H parameter when we are using for transistor, it is also called as H model. Now in this video we will see what exactly H parameters are. So before going to that one, we will just review what is being taught in the last one. A very fast review will take. We know transistor is a 3-terminal device. So this transistor is a 3-terminal device. To connect it into the circuit, we need one terminal as a common. So suppose this is emitter terminal, this is base terminal, this is collector terminal. Suppose we are taking emitter as common. So this input side and this output side. So this input side, let us assume it is denoted by 1 and 1 dash, output side as 2 and 2 dash. The input voltage is V1, input current is I1, output voltage is V2 and output current is I2. This can be equivalently represented by using a model. A model is, this box is actually a model. In two-port network theory, you know what is the model. Different models are there, ABCD model, Z, Y, all these are the models, and the parameters, the corresponding parameters are called as the parameters. So Z parameters, Y parameters, ABCD parameters, H parameters. In the last video, we know that H parameters suits our requirement. So we are using for transistor. So this model is our H model for transistor. What it contains? Same thing, only this thing in the transistor we are representing by the model. So it is I1, it is V1, this is V2, this is I2. That's all. It's only 4 variables. It is the play of only 4 variables. Play of 4 variables. What are the variables? Input voltage, input current, output voltage, output current. That's all. From these things we want to calculate our 4 different parameters like voltage gain. I am telling you in the brief the general outline. Voltage gain we are calculating, current gain, then input resistance and output resistance. That's all. So this 4 parameters we are calculating by using the model. So let us see, this is the brief overview. Now let us see the actual representation. What is H parameter? So as I told you, this H parameters, what we are doing, we are considering the V1 and I2 as dependent variable. So this V1 input voltage and output current as dependent variable. On whom they are depending? They are depending on I1 and V2. So this I1 and V2, they are independent variable we are considering. And what we are considering, the V1 and I2 are the functions of I1 and V2. Both are functions of I1 and V2. So we know from the H parameter definitions of two-port network, this V1 and I2, they are H11 into I1 plus H12 into V2, and I2 is H21 into I1 and H22 into V2. How we got this equation? Generally from this equation, if we are using H parameter, what we used to write in the matrix form, V1, I2, they are dependent on 2 variables, other 2 variables, that is I1 and V2. And what is this? This is actually your H matrix. This is the H matrix. How you are writing this H matrix? Generally you are writing H matrix, any two-port network parameter matrix like ABCD matrix or Y matrix or Z matrix. What you are writing? You are writing H11, 12, 21, 22. Like that only we are writing. So here also what we'll do, we'll write here 11, 12, 21, 22, and we are using H parameter, so we need to write here H. So this is H, this is H, this is H. So all these are H. So let us allow me to write it in the proper way. I will write in the proper way now. If you understood, I will write it to the proper way. So this matrix will contain what? H11, H12, H21, H22. What are these? H11, H22, all these things are actual parameters. We need to calculate their values, and we'll definitely calculate these values. Generally, to calculate these values, we use different equations. So the first two equations, the basic equations we got is this. If you just multiply H11 into I1, we will get, then H12 into V2 we will get. For I2 what we will get? H21 into I1, then H22 into V2. That's all. So it's very easy, very simple. What you need to just remember, the H model. Now generally this H11, H12, H21 and H22, they are defined. How to calculate? Suppose we want to calculate H11. What is H11? If you want to calculate only H11, what is H11? It will be V1 by I1 when V2 is 0. So you need to make V2 as 0, so as H11 will be simply V1 by I1. So V1 by I1 is actually your input resistance. So this input resistance, as it is input related to input, it is given by I. This is denoted by IEEE standards. This 1 is actually your I. This 1 is actually your R. It is the reverse voltage gain. Right? You can verify. H21. This H21 is actually your F. F means forward. It is forward current gain. Therefore, it is denoted by F. H22. 22 is I2 by V2. It is output admittance. So it is denoted by O. So if you replace it, what you will get? What you will get? This H11, V1 by I1 HI. H12 is V1 by V2. Yes, of course, provided I1 is 0 here, provided V2 is 0, in that equation you need to do that. So HR, like this, you will get 4 parameters. These 4 parameters from these two equations you need to calculate. So this is the basic definition. Now, if you see the model from these two equations, if you are just comfortable with these two equations, you can easily construct this model from this equation. How to construct the model from this equation, we will see in the next video. In this video, what is our aim? What was our aim? Just to introduce these two equations, and what is HI, HR, HF and H0. Only these things. Now in the next video we will see how to construct this model, this complete model. This is the model actually, and we will use this model extensively. We will use it till our last H parameter model comes, last parameter will come. We will use all these things. So we will see how this is made using these two equations in the next short video. Thank you.